This is the last night of the Rock Hound workshop, and we're going to talk about minerals.
So hopefully you have all taken out your A samples or have them kind of in front of you. Those are the minerals. We're going to work with minerals today. So just to recap, everything that we've covered pretty much until now was rocks. What's the difference between rocks and minerals that we're covering today? Can somebody tell me? Way back there. What's the difference? Rocks are made of minerals. That's like the easiest, best answer you could give. That's exactly right. So minerals are the pure, the clean, just one thing all the way through. Rocks are a combination of multiple minerals put together. So that's the difference. Here's a list of all the minerals that you guys need to know for this event. You'll notice that I have 3 that are in red here with little asterisks. These ones are special just for 2015. So I'm going to talk about these ones as well as all the rest of them. Okay, so last week we talked about all these different mineral properties, right? Color, sometimes it's very helpful, sometimes it's less helpful. Streak, that's what that little tile is for that's in your kit. It tells you, you can look and see what color the powdered mineral is when you scratch it on there. Luster, that's the way that the light reflects off of it. Hardness, that's how hard it is, particularly in relation to all the other samples, relative hardness. Density, that's like how heavy it is if you have 2 pieces that are the same size, which one's heavier. Crystal shape, so that's the size that the crystal, or the shape that the crystal forms into. Cleavage, that's the way that the mineral breaks when it breaks along those crystalline lines, so along the internal lines. Fracture is the way that it breaks when it doesn't break on those cleavage planes. Fluorescence is what happens when you put the black light over it, ultraviolet light. And reaction to acid, whether or not it bubbles or foams when we put acid. We usually say hydrochloric acid as a basic line. So the first one we're going to talk about is the mineral calcite. So everybody grab sample 2A for me. And am I right that you got a special sample of blue calcite this year in your kit? Am I right in saying that or no? No? Ron talked about that maybe happening, but maybe not. So sample 2A, can somebody tell me what color your sample is? What color is yours? What color? White. Does anybody have a sample that they would say is not white? What color? Little bits of red. Okay, how about yours? Yours is clear. Okay, I'm with you. How about yours? Milky. Okay, so probably still in that white category. What else? A translucent gray. Okay, so most of yours are pretty pale color. That's the most common color to find calcite. Most often if you were out in the field and you found a piece of calcite, it'll usually be white. But it often can be almost any other color. Literally, there's almost no color I haven't seen in calcite before. It can be literally every color. The streak, everybody rub it on your streak plate just a little bit and see what color yours is. It should be white or nearly white. The luster is really varied. It depends on the sample, depends on how the crystals form together. Sometimes it's really shiny and vitreous. Sometimes it's really pearly. Sometimes waxy or greasy sometimes. Calcite is the number 3 on the Mohs hardness scale, right? So it is the 3. Let's see, what else? Density. So I'm going to use this number. Everything on all these pages I have densities. And it's in that grams per cubic centimeter or grams per milliliter. And I just want you to notice when they're higher or lower. This one is 2.7, which is going to be a pretty common-ish number. Most of them are in the 2-ish and 3-ish, 4. Most of them are average about 3. So just be aware when I say this that you'll notice if one's particularly higher or lower. So the density is 2.7 grams per cubic centimeter. So calcite has a really interesting cleavage shape. The shape that it breaks, when it breaks into pieces, it breaks into these what we call rhombohedrons, which are up here. So those corners, none of them are at 90 degrees. They're all kind of squished. They're parallelograms, right? Rhombohedrons. that to me is the best identifying factor for calcite. When I'm in the field and I find a pocket of crystals, I look for a broken edge, and you can see those little rhombohedral breaks. Calcite almost always breaks on those rhombohedral cleavage planes. Sometimes you'll see conchoidal fracture. It's pretty rare. Like this particular sample is a real waxy looking piece, and it doesn't have good crystal structure. So it can't break on those rhombohedrons. In this case, it'll have a conchoidal fracture. 95% of the time, you're not going to see any fracture. It's going to break on those cleavage planes. Now, calcite does a number of different crystal shapes. So that's the way it breaks. This is the way that it forms. Okay, these are the crystal shapes. The most common one probably is the dog tooth. And we call it a dog tooth because it's pointed, just like a dog's tooth. It doesn't go up and then go to the point. It starts at the bottom and goes right to the point. So that's called a dog tooth. It generally will have about 3 faces. Sometimes it's difficult to see the 3 faces, but there's usually 3 faces. Another less common, but still you'll occasionally see crystal shape, is called the nail head. So the sides are parallel, and then it comes to a termination at the top. It looks a lot like a nail. Again, usually you'll see 3 faces on the top, usually. Also, sometimes the crystals will actually form into those same rhombohedrons that it breaks into. So the same sort of shape can sometimes be a natural crystal as well as the way that it breaks. So calcite is sometimes fluorescent, which is pretty cool. When we put that ultraviolet light on it, sometimes it does different things. So that's in regular daylight, and then actually the first one is shortwave and the second one is longwave, which is a different kind of black light. But sometimes calcite glows under the black light. It also reacts with acid. So if I asked you which mineral reacts with acid, and you could identify a piece of calcite, you'd know that that's the answer. Calcite will react with acid. It has this really cool feature called double refraction. So what happens when you have anything that you put underneath a piece of calcite, if you have a piece that's clear enough for you to see through, it doubles the image. It makes it go twice. I have a piece here that we can maybe see it on the camera. Afterwards, you can probably see it if you take a look in person. So this double refraction is really cool. Let me show you some pieces that I have here. Okay, so this one is a dogtooth crystal. You notice that all the faces start at the bottom and go right up to the point. This one, instead of having 3, it's actually got more like 6, because each one kind of doubled itself. If you look on the bottom, it broke on a really smooth face. This is one of those cleavage planes. And if you look through the side, you can see the angles of those cleavage planes, of those crystal lines, going right through it. So they look like little cracks right where the cleavage planes are. And if you hit it, it would break on those cleavage planes. This one is a nail head. So it's got 3 faces around the point, and it comes up pretty tall, pretty straight from the sides. Again, the bottom, you can see those rhombohedral breaks. So even if you didn't recognize this shape on top, you should be able to recognize the way that it broke on the bottom. Now this one is just a broken piece. So this is a rhombohedron. This broke into this shape on the cleavage planes. It's pink colored, and actually in the right light it almost looks clear. And the reason why it's pink is it's actually glowing under the UV, the ultraviolet light that's mixed in with the black light. It's so fluorescent that it actually looks pink under regular light. Let's see if we can see the double image. I can maybe zoom in. Can you see it? I don't know if it'll focus. No. Okay, we'll check this one out afterwards. This is really neat. It's a really cool piece. Okay, does anyone have questions about calcite? Yeah. Can calcite have a marbleish look? That's a real good question, and sometimes it can, because marble is actually sort of made out of the mineral calcite, mostly. Most of what's in marble is calcite. So definitely, sometimes calcite looks a little bit marbleish. Absolutely. What else? What is calcite used for? That's a real good question, and I didn't have anything on the slide here. Calcite it's relatively rare in its pure form. So most of the time, if like the chemical industry or anything needs to make something out of calcite, they'll use either marble or limestone because they're chemically basically the same. It could be used for a number of things. Could be used in cements or plasters or all sorts of things. It's not usually, though, just because it's rarer to find. I believe it's used in some specialty optics for that double refractive, like certain crazy machines sometimes use it. But I don't know what else. I don't know. All right, so the next one we're going to move to is Galena, sample 4A. So everybody find your sample of Galena. Tell me some of the features that you notice about Galena when you first pick it up. Just some of anything, any feature that seems notable. What do you think? It's heavy compared to its size. That's a great one. That's a really good observation. So you can see here the density is 7.5 grams per cubic centimeter. Remember, calcite was less than 3. It was 2.7 or 9 or something, less than 3. So it's very dense. It's real heavy for its size. What other observations? What do you see? It looks like metal. That's an awesome observation, right? So it's sometimes on a freshly broken surface, it's really shiny. It looks like a mirror almost, like chrome. Really shiny, silvery metal. Sometimes it's dull, but it still looks like a metal, right? Metal is a really good term. What other feature is really noticeable? Yeah. It has layers. That's a good one. That's a good one. So those cleavage planes that we'll talk about in a second, make it break into what appears to be layers. Absolutely, you notice layers. What else? It breaks in squares. That's another really, really good observation, right? So it breaks into those 90-degree corners, into like cubes and squares and rectangles, right? What else? Say it louder. The sides are angular? Yes, yeah, absolutely, because of that cubic cleavage. So everybody take and do a little streak on your streak plate. So it kind of leaves like a little silvery streak, right? That could help you in identification too. But in general, Galena is pretty easy to identify based on those things we talked about already. So what's the fracture of Galena? You don't usually see a fracture because it breaks on cleavage lines so easy. So you notice that there was layers, and it's because there's all these crystal lines that it just wants to break on, each of those lines in the crystal structure. That's the cleavage planes. And they all happen at 90-degree angles. So everything happens in squares and rectangles when Galena breaks. Also, when you see Galena crystals, you often see cubes. Not always, but very often, they form in cubes, those same right angles, the same squares. But octahedrons are sort of a cousin in the mineral world, in the crystal world, to cubes. So these octahedrons, which means 8 faces, right? There's 4 around the top and 4 around the bottom. Sometimes you'll see octahedrons in Galena as well. That's less common, but you still see it sometimes in the crystal shape. It'll never break that way on the cleavage planes. So what do we do with Galena? Galena is a really good ore of lead. That's why it's so heavy, right? Lead is really heavy stuff. And what do we know about lead? Lead's bad, right? Lead is a poison. It's not good. It's a heavy metal. It can build up in your body, it can build up in the environment, and it can cause a lot of bad stuff. So what did we used to do with lead before we realized how bad it was? They used to put lead in gasoline back in the day. It helped lubricate the engines and keep them running better. They stopped doing that about, 40 years ago. We used to put lead in paint, right? And they stopped doing that even further back because kids were eating little flakes of paint and then they'd get lead in their body, right? That was bad. But it was really good for both of those things. It's no longer used. We still use it for a number of things. We still make bullets a lot of times. They're starting to do them out of other things in some circumstances, but most bullets are still made out of lead. And sinkers, if you ever go fishing, usually your fishing sinkers or weights, those are often made out of lead. So there's a number of uses that we still do with lead, and galena is an important ore of lead. Does anybody have questions or anything to add or ask about galena? Yeah. Sure. Yep. That's right. He mentioned that old civilizations a long time ago used to make sculptures out of lead. I've never seen it, but I certainly believe it. Lead was one of the first metals that people were able to do stuff with. And, you know, I've heard that the Roman Empire, a lot of their pipes were made entirely out of lead. And it hurt their civilization in the long run. A lot of them were being poisoned by the lead. We still use it in solders for electrical things. Not so much in plumbing anymore. They've gone away from lead solders and plumbing. Lots of things, all sorts of things. What else?
Wasn't lead also used for pencils?
Wasn't lead always also used for pencils? That's a great question, right? Because we call it a pencil lead in there. I don't know. It may have been used at some point. But what's the stuff inside of a pencil? Does anybody know? Graphite, right. So graphite's what's inside the pencil. We call it pencil lead, and maybe it was used. That's probably where the term came from. Makes sense. Is it used in mirrors? I don't think so. But it sure does look like a mirror, doesn't it? It really does. All right, next let's move on to the quartz family. So there's a whole bunch of minerals in your kit that are quartz family. So if you could grab them all out, we're going to kind of talk about them together. I don't know if your list has them denoted, but there's quartz crystal, there's amethyst, there's citrine, smoky quartz, rose quartz, and milky quartz. Is that all of them? Quartz chert? Okay, so I'm going to talk about the quartz family as a group because they're all the same mineral and they share most of their properties. Quartz is the number 7 on the Mohs scale of hardness, so it's pretty hard. It's one of the hardest rocks in your kit. Its streak is white, sort of. It's actually harder than your streak plate, so if you scratch it on your streak plate, you're really powdering the streak plate instead of the quartz. But its streak would be white if you had a harder streak plate. Its luster is often vitreous or adamantine or glassy. It's sometimes greasy, could be other things. Depends. Could be waxy. Its density, 2.6 grams per milliliter, or grams per cubic centimeter. So similar to the calcite, right? That's very close. It's about the same density, much, much lighter than the galena. When it comes to quartz crystals, the easiest way to identify them is their crystal shape. Quartz has a hexagonal crystal, which means 6-sided. So quartz crystals have 6 sides. They're in symmetry of 6. Now, you won't always find perfect crystals. In the perfect world, a quartz crystal is usually a column, and then it comes to a point on the end. Sometimes you'll get just a portion of the crystal, or you only see part of it, or sometimes the crystal just grew funky and didn't grow quite right. But usually, almost always, you can count the 6 faces all the way around. Even though sometimes there'll just be a tiny one off to the side. There should be 6. So, quartz doesn't really have a cleavage. There's no cleavage planes in quartz. So when it breaks, the very pure specimens, the clearer they are, the more likely they are to have a conchoidal fracture. When they're more dirty or impure, like most of the milky quartz samples, it tends to be a little bit more uneven, and you don't notice that shell shape of the conchoidal fracture. So those are the different ways that you'll see it break. We actually grow a lot of quartz in the laboratory, and most of it is used. Does anybody know what most of it's used for? What do you think? Windows? Not so much. It's pretty expensive to grow compared to glass. Anybody else have a guess? What do you think? Not so much in mirrors. What do you think? Jewelry, you're getting closer. They do actually make some lab-grown quartz for jewelry. So you're right, but that's not the answer I'm looking for. What else? Watches, that's the answer I'm looking for. Okay, so have you ever noticed in watches or on a clock it'll say quartz on there? That means that it's got a teeny little piece of a quartz crystal. They grow these lab-grown quartz crystals, and they cut just a little tiny piece out of them, and they wrap a coil around it and put electricity through it. And quartz has this really interesting property called piezoelectricity. And what that means is that when you put electricity through it, it vibrates. So it shakes just a little bit when you put power through it. So what's really cool, they figured out a long time ago that if they put power through a quartz crystal and then they count how many times it shakes, they can tell time. And I don't remember the amount of times, but it's a really lot. Like every 10,000 shakes is like 1 second that it ticks your watch or ticks your clock. It's a really lot. And it actually works in reverse too. If you can shake a piece of quartz, you can actually generate a little bit of electricity out of it. So it works both ways. But in watches, we put electricity into the quartz crystal, we measure how much it shakes, and then it helps us count the time off. So here's our different colors. And when we talk about the quartz family versus each of these different varieties, the only thing that is making the variety have its name is its color. So when the quartz is purple, we call it amethyst. So you would be totally right if you said it's quartz, but if you wanted to be more specific, you could call it amethyst, because amethyst is purple quartz. So the same goes for all of these different varieties of quartz. All these names just have to do with the color or the way they look. Milky quartz, right, looks like milk. It's white. Rose quartz is always a pink color. Sometimes it's a pretty faint pink. The really good dark pink stuff is pretty rare. And there's a lot more of it that's pale pink, real pale sometimes. So you might see that more often. There's quartz chert, which actually, according to a lot of geologists, is actually sort of a rock too, depending on how it formed. But it's definitely still quartz. It's pure quartz. Smoky quartz is either black or gray. Citrine has a big range of colors. If it's even a little bit yellow or brown or orange or reddish, we call all that citrine. And then quartz crystal is just the plain clear quartz. So quartz is used for gemstones. Almost all of those last ones are gemstones. They're jewelry. I use them all the time at work. Another variety that's not on your list that I want you to be exposed to is called cinnamon quartz. This one's a special one. It's actually only found around Lake Superior, or mostly found around Lake Superior, particularly in Canada up to the north, but you can find it in other places too. It's usually amethyst, but then on the very outer layer, as it was forming, it got iron oxide crystals stuck into the quartz. So this is basically like rust that got stuck inside the quartz as it was growing. Many of the pieces, if you look at the bottom, you'll see it's purple. It's really an amethyst that has this reddish or brownish tint to it on the outside. There's another type of quartz that we see sometimes. It's called rutilated quartz. And these are little tiny crystals of a mineral called rutile or rutile. And they look like gold hair. It's really beautiful stuff. It's amazing to look at. So it's an inclusion. It's another mineral that's stuck inside the quartz. Same thing with tourmalated quartz. So tourmaline is another mineral that sometimes gets stuck inside the quartz. And we call it tourmalated quartz when we see that. Let me show you some of the samples of quartz I brought. So this one is a crystal quartz. It's pretty foggy. You know, I wouldn't quite call it milky quartz, but it's definitely not crystal clear. If you look around the top, you can really easily count one face, 2, 3, 4, 5, 6. So this is a real good example of 6 faces. Now most of the bottom part has been broken off on this crystal, but you can see the point, which we call the termination, and you can count the 6 all the way around it very easily. This one has 3 big faces, one right here, 1, 2, 3, and then it's got 3 little faces hiding down here, 1, 2, and 3. So they don't always reach to the point. Sometimes they're hiding somewhere else. But if you look really close, you can find them. Now this has a nice conchoidal fracture here too. That shows you how it breaks, particularly when it's nice and clear, which you can see this piece is pretty clear. So that's how that piece broke. Here's a sample of amethyst. It's purple. And you can count around, again, 6 around each face. And the crystals are pretty short and stubby on this, but they're a nice purple color. Here's a piece of citrine. It's pretty light. Sometimes they're really dark. This one's a little on the light side. And again, the crystals are pretty short and stubby, but if you take a look at each individual one, you could count the 6 all the way around it. Here's a geode. Found this one in Kentucky, and it's got small quartz crystals in it too. Here's some rose quartz, a darker pink and a lighter pink. You can see a nice conchoidal fracture on this one too. This one is an agate, which is similar to the way that the chert forms. Not quite, but it's a close cousin. Agate is also a type of quartz. This one is a chert. It's got different colors. This one's a smoky quartz. It's got black crystals. They're almost jet black. Then here's a sample of the cinnamon quartz I was telling you about. It's a reddish brown color, and if you look on the bottom you can see it's purple. So most of the time it grew like amethyst, and then just the very outer layer, it got that iron oxide, that rust stuck inside of it. Does anybody have questions or comments about quartz? What's up?
My cookie is more like clear.
Okay.
Why is that?
All right, so she said her smoky is more clearish. Smoky quartz, actually all of the colored forms of quartz are much more rare than clear quartz. And quite honestly, the darker they are, the more valuable they are. So to keep the costs on the kits down, sometimes there's not a lot of color saturation in the samples they use, because it could get pretty pricey if you have really darkly colored ones. So in your smoky, it probably has a little bit of gray or a little bit of something, giving it some color, but you know, it's maybe not the best piece, would be a good way to put it. What else?
How do you tell the difference between lab generated?
All right, she asked how you tell the difference between lab-grown quartz and real quartz, which if you have a piece, if you have the crystal itself, like this lab-grown crystal, The surface is really funny looking. It doesn't look like any natural crystal. It looks all bumpy on every other face. This one's real smooth, and then this one's bumpy. So once you've seen one piece of this, you'll notice that it's different than regular quartz. As far as when it's cut into a gemstone, it's pretty difficult. It's difficult to tell because property-wise it has the same hardness. It's tougher to tell. Has the same refractive index. So you have to use some other equipment to try and determine, machinery to tell the difference sometimes. Yeah. Okay. All right, so she said her chert is very smooth and was wondering if it always breaks that way. It does. It usually breaks in these pretty smooth and like chalky kind of breaks. It doesn't break real jagged very often. Chert is a close cousin to flint too, which is what the Indians used to make the arrowheads out of, right? Chert and flint are sort of the same thing. So it tends to break into these smooth-ish areas, and the very edges can be very sharp when it breaks sometimes. Yeah? You gotta speak real loud for me. Are there other uses for quartz? Probably. There's a lot of uses. Quartz is a really common material. So there's a lot of different things that people do with quartz. More recently, the last 5 or 10 years, they've been making those countertops out of quartz. They sell them as quartz countertops. And they use natural quartz and then glue them together, cement them together somehow into countertops. There's all sorts of stuff that they do with quartz. Yeah? Can smoky quartz be colorless? No. If it's entirely colorless, we would call it quartz crystal or crystal quartz. It should have a little bit of gray, just a little bit or a little black, something in there to call it smoky. Yeah? Okay, he asked if chert quartz might have better crystals sometimes. That's something I didn't address that I should have. Chert never forms into those hexagonal crystals. The way that chert forms, it forms in these like rounded balls almost always, or globs at the bottom of the ocean most of the time. It never forms in a crystal. So you'll never see a piece of quartz that you can count the 6 faces around that was quartz unless it was cut that way or fashioned that way. It'll never naturally form a crystal. Yes? These guys?
Yeah.
Okay.
How rare are they?
They're pretty rare. They're pretty rare. They only happen in very certain cases. All right, let's move on to graphite. That's sample 15A. What's the first thing that you notice about your sample of graphite? What do you think?
Well, if you put it in your hands and just like rub it around,
Uh-huh.
if you did it with shed, nothing would happen. But if you do it with graphite, it would be like a magnet.
Gotcha. So she said if you rub the graphite around in your hands, it's going to leave black stuff on your hands. Absolutely, right? What else? It looks like chalk. It kind of does, right? It's really soft. It's chalky, kind of like chalk. What color is it? What color? Black. It's either black or a very dark gray, right? It's always a really dark color. It's really soft. I shouldn't say always. It's occasionally silver too, but most of the time it's black or gray. How hard is it? If anybody dares to take theirs out of the bag, can you scratch it with your fingernail? Yeah. So your fingernail's what, a 2.5 or so. So it's less than that. It's like a 1 or a 2, depending on, how it formed and what it is. The streak kind of looks like pencil lead, right? Silverish, grayish. It's got a basal cleavage sometimes. It's hard to see. A lot of times graphite forms in metamorphic rocks. So it doesn't have all the same characteristics that you might hope to see. So you may not see a good basal cleavage, but it does, especially if you look at it under a microscope. You'll see that there's small crystals that are breaking in flat parallel planes, okay? Crystals are pretty rare. They're pretty rare, but when you find them, they're hexagonal. But you don't often see them. Octahedral crystal, I've actually never seen one in person. That I found on the internet. The fracture is uneven. It generally breaks pretty just irregularly, most of the time. So why does it feel so soft? Why does it scratch away so easy? It has a layer of very weak atomic bonds. So it breaks off and slips and slides. And you'll notice when you get some on your fingers, it almost feels slippery, like greasy or oily in your fingers. Like makes it really feel smooth in between your fingers. For that reason, it makes a really good lubricant. So like keys in a lock, they'll put graphite powder, or sometimes when you have like a brake cable in your bicycle, they'll put graphite powder in there because the oil will get gummed up and stuck. Graphite powder is a really good lubricant for that. I would say the most common use that we think of when we think of graphite is the lead in lead pencils, right? We grind it up, we mix it with a little bit of clay, and then form it into these rods and put it into pencils. So lubricants, pencils are the primary uses of graphite. Now I know I don't really like to get into chemical formulas with you very often, but does anybody know what the formula is of graphite, or what chemicals, what on the periodic table graphite might be? What is it? Graphite is not poisonous. What do you think it is? It's carbon, right. It's pure carbon. Graphite is pure carbon, which is pretty cool. We call that a native element. So when it's just one element, there's nothing else bonded in there, it's just pure carbon. So that's pretty cool. I have a piece of graphite that I don't know if I want to take out of the bag. I can show you. It's a really dull black, powdery. You can almost see some layers in it. And I don't like to touch it. All right, anybody have anything else to add? Questions, comments about graphite? What do you think? Sort of. He asked if the atoms were bonded in a different way, wouldn't it be diamond? Yes. Diamonds and graphite are both pure carbon. So if the atoms were arranged in a different way, it would be a diamond. Yeah. What else? Yeah.
It's not toxic, it's not for lead.
Right. Yep, no lead in there. What else? If you rubbed it on cement, would it show up? Definitely it would. You'd probably wear the whole piece away in just a minute. But it would show up. Yeah. So is it soluble in water? I don't think so. I think it would stay together. I think it would. Ron, did you have something you wanted to add? Gotcha. Thank you. Yep. What else? You got to speak louder for me. Can it be used for chalk? It probably could be, yeah. Graphite is pretty expensive for what it is compared to chalk. So I think if somebody were to make chalk, they would just use chalk and mix it with some black dye or something. But it would work as chalk for certain because it's real soft and it's really dark. So it would powder and look like black chalk. All right, one more question. Is it used for anything else? I'm sure it is. I don't know what else. But graphite being pure, you know what? Here's another good one. There's a new stuff that they came out with called graphene, which is actually graphite one atom thick. They take just one layer of this, and it's going to be, science is saying it's going to be all sorts of cool stuff. A semiconductor, and it's really strong. I don't know what else it does, but That's a cutting edge science. They've only been doing that the last few years. So graphite is pretty exciting stuff. All right, so next we're going to talk about mica. So in your kit you have muscovite mica, biotite mica, and is there lapidolite also? So grab all those ones out. We're going to talk about them together. First, let's talk about the biotite mica, just by itself for a sec. Can somebody tell me what color their biotite mica is? What color? Black. Does anybody have one that's not quite black? All right, so yours is not quite black? A little bit of yellow in some spots. Okay, what else? Brown. Yep, it's usually either super, super dark brown or black. And that yellow that you're seeing, I think, is usually where it's like almost ready to flake up, and you're looking at a layer that's so thin that it kind of has a little yellowish tinge. I've seen that before too. So biotite mica is black, almost always black. How about your muscovite mica? Can somebody tell me what color your muscovite mica is? What color is yours? Whitish gray. Okay, anybody else? Chrome. Okay, so like silvery looking. How about yours? Almost clear. Excellent. That's a good one. What else? Goldish. Good observation. How about yours? Yellowish. Greenish and brownish. Okay, I'll believe all those things. Yellow. Okay. All right, so muscovite mica is always lighter than biotite. So biotite is almost always black or really dark brown. Might have like a touch of green or yellow in it, but really dark. Muscovite is going to be lighter. It's oftentimes silverish or goldish. All those colors that we listed off are perfectly possible colors for muscovite mica. So the important thing to remember is the biotite's the really dark one, and muscovite is silvery or whitish or goldish. Now, how about your lapidolite? Can you tell me what color that one is? What color is yours? Sure. Purplish or pinkish. Those are the two colors that I was looking for. So the lapidolite is purplish or pinkish. Now, is your sample of lapidolite, does it have layers the same as your muscovite and biotite, or no? Yes, no? Somebody tell me. No? They oftentimes don't. Again, lapidolite's pretty rare. So a lot of times the samples you'll get in a kit won't have nice layers, just based on how it formed. Let me move on here. So the fracture. We don't really see a fracture very often in any of the micas. What we usually see is the cleavage planes, right? You notice that your pieces almost always have a top and a bottom that's flat, right? That's because those are the cleavage planes that it broke on. And you can almost just keep breaking it. If you wanted to destroy your piece of mica, you could keep flaking it into thinner and thinner and thinner pieces until you could see through it easily. You could take it super, super thin if you had a razor blade. It just keeps going into thinner and thinner pieces. So oftentimes if you find crystals, they're hexagons. They're mica, all the mica family has hexagonal crystals. Now it doesn't come to a point like the quartz does. It'll usually have a flat top because it broke on that cleavage plane. But if you look at the outer shape, you'll see a hexagon. Sometimes you'll see blades. That's not too uncommon to see. Sometimes you'll see roses. They're beautiful. Mica makes some really cool rose shapes sometimes. So we talked about the different colors that you get, right? The black biotite, the silverish, the goldish, yellowish, whatever it might be, muscovite, and then the purplish lapidolite, which might be more massive. That's probably what's in your kit. Or it could be more flaky like the other ones. So what do we do with mica? Mica is an awesome insulator of heat. What does the word insulator mean? Does anybody know? What does it mean? It keeps heat in. That's a really good way to put it, right? Like insulation in the walls keeps the heat in the house. Insulator means it doesn't conduct through it very well. Insulator is the opposite of a conductor. So if it's an insulator of heat, that means one side could be really hot, and if you put the insulator in between, the other side wouldn't be as hot. The heat wouldn't travel through it. So it's a very good insulator of heat and electricity. So if you look in a really old toaster, you'll see sometimes actual full sheets of mica that they wrap these heating coils all the way around. And I think in modern toasters they still actually use mica that they grind up and kind of glue it back together. They don't go through the trouble of finding nice big pieces anymore. But mica is an excellent insulator of heat. I have seen a couple of old wood-burning stoves that the windows on them were very crystal clear pieces of muscovite. I've heard stories that back in Russia, years and years and years ago, they used to make windows out of muscovite crystals. They would, break them on their cleavage planes. They called it isinglass, was the term for that. It's a very, very common ingredient in makeup. If you look on almost any makeup, you'll see some mica because it powders really smooth. And another thing that it does is it gives that shimmer. Has anybody ever seen the lotion or makeup that gives you a little bit of sparkle on your skin? That's tiny little mica crystals. Also, if you go to the movies up here, the AMC Forum 30 or some of the other ones, and in the sun they have that cement that sparkles like glitter in the sun, looks like diamonds. Those are little tiny bits of mica that they stuck onto the top of the cement before it dried. So mica is used for an awful lot of things, primarily in cosmetics and as an insulator. But it's used for other things too, I'm sure. Does anybody have anything to add? Ron, you have something? Excellent. Thank you, Ron. So out west, they would use the mica for windows as well. What else?
You said at the old heaters they would put sheets of mica on the floor. Over time, wouldn't that corrode and fizzle away?
No, I'm saying at new theaters, like the AMC Forum 30, they put outside in the cement. They put little bits of mica. And it does sort of peel away with time.
Some people they might some people would eat and that
Yeah, mica is so soft that it breaks on those layers, so it does eventually look not nearly as sparkly as it did when they first put it in. I don't know. Probably not. What else? So she asked why the lepidolite is harder than the biotite or the muscovite. Now, truly, the minerals themselves are very comparable in hardness, but your samples are different because the lepidolite sample you have is probably more massive, which the crystals are more tangled up. So it gives it more of a hardness, or toughness might be a better word, than the other flat pieces. So the hardness is maybe technically the same, but the toughness is a lot stronger when it's massive like that. Okay, let me show you a few pieces of mica that I brought with me. So here's a piece of biotite. It's almost entirely jet black. You'll see a little bit of brownish or yellowish, kind of where it's flaking away. Look at that. And it sort of has a hexagonal shape, right? You can see one good, 1, 2. Then you have to kind of imagine this one, 3, 4, 5, and 6. So it's sort of got a hexagonal crystal shape as well. Here's a piece of muscovite. And it's real silvery. It almost looks metallic-y or pearly. And again, this requires a little imagination, but this angle right here is the outer edge of a hexagonal crystal. See how the angle lines up with this one? So this was a much bigger hexagon at one point. Here's a piece of lepidolite. That's almost a perfect hexagon. And it's a nice purpley pinkish color. This is a different type of mica. It's actually none of the above. And it's got a greenish color. So I wouldn't expect you to identify it, but if I showed it to you, I think you could expect to identify it as mica. All right, so next we're going to talk about fluorite. So grab sample 3A. Can someone tell me what color your sample of fluorite is? What color is yours? Green. Okay, does anybody have one that's not green? Tell me what color. What color? Light blue. Okay, so we got green, we got light blue. All right, what else? Yep. Light green. Okay, what else? Light teal. Okay, so we got greens and blues. Anything that you wouldn't say is like a greenish or a bluish. What else? Aqua. Okay, that's bluish. What else? Yeah. It's a greenish. Okay, so it seems like most of your samples are greenish or bluish. Is yours not? It's what? Part of it's yellow. Okay, part of it's yellow. Fluorite is another one of those cool minerals like calcite that can be almost any color. So color is not going to be a good factor to help you identify fluorite. Its streak is going to be white, so that's also not real helpful in identification. Luster could be a number of things. Hardness is 4, so it's the 4 on the Mohs scale. Density 3.2, again, that's pretty close. Most of them have been around 3-ish unless they're something too interesting. But look at all these colors, right? Can be tons of colors. So fluorite has an uneven fracture. It kind of breaks irregularly when it breaks on its fracture lines. But more often, you'll be able to notice some fracture lines. I imagine that most of your samples will have at least one or hopefully 2 faces that have some cleavage on them, that you can see the way they intersect. So in a perfect world, if you could have all the faces cleave nicely, it'll form these octahedrons, these 8-sided double pyramids. Occasionally they will form crystals in this octahedral shape, but more often they form crystals in cubes or some form of a cube. So rectangles or squares is most often the shapes that you see. So what do we do with fluorite? We put it in glass, we put it in enamel, we make special lenses out of it. Hydrofluoric acid, right? There's fluorine in fluorite, so we make that. Used as a flux to smelt materials. Fluoride for toothpaste can be extracted from fluorite. It's also fluorescent, or can be fluorescent. Is almost always fluorescent. Who am I kidding? With a name like fluorite, that's actually where the term fluorescent came from, is fluorite. So it is almost always fluorescent. It can fluoresce a number of different colors. Let me show you a few pieces I brought. Now we've still got a lot of material to go through, and I've spent a long time, so I'm going to try and speed it up a little bit because I want to get through as much as I can for you guys. So this is an octahedron. This is a piece that cleaved out into this shape. Double pyramid, 8 faces. Each face is a triangle. This is a crystal. You can see this is a 90-degree angle running down the middle, so that's cubic. And if you look really close at the surface, there's all sorts of little cubes there. This one is also cubic. Here's a good corner of a cube. And it's both yellow and purple. So fluorite can be almost any color. It often breaks into these octahedrons, and it often forms cubes. Gypsum is the next one. So I think we've got, 5A and 11, which is going to be selenite and, is it satin spar? Are those the two you guys have? Okay. So gypsum is pretty soft, right? You should be able to scratch it with your fingernail. It's the 2 on the Mohs scale. Your fingernail is about a 2.5. so you should be able to scratch it. It can be a lot of different colors. It can have a lot of different lusters. Sometimes it can be pretty sparkly, sometimes it's silky or dull. It's really cool. I want to highlight this picture here. This was down in Mexico. I think it's about 10 years ago now that they found this crystal cave down in a mine. I forget what it is, a copper mine or lead mine, I don't know. But these are giant gypsum selenite crystals, and that's a guy right there in here. So this cave is just full of huge crystals. It's really cool. But it's so hot in there. It's really hot. You have to wear special suits to keep you cool, and even that, you can only stay in there for like 10 or 20 minutes before you overheat. But it would be absolutely amazing to see. So the shapes that it forms in is monoclinic crystals quite often. Sometimes you'll see roses. That's not too uncommon. Sometimes you'll see these elongated crystals, like little fibers almost. The splintery fracture, sometimes it'll break like your gypsum satin spar. Has a rhombohedral cleavage. The two faces generally break pretty good, but all the other sides, they don't break real nice like calcite. Calcite breaks good in all the directions. This one only breaks good on the one way, the top and bottom. So it's slightly soluble in water, which is useful to us for a few different reasons. I'll tell you about in a minute. So we find it in different ways. There's massive gypsum, which is by far the most common form of gypsum. We use that for a lot of industry. There's gypsum selenite, which is crystals. So that's when it's got actual crystal structure. It's quite often clear or clear-ish. There's a fancy shape that we like to call the fishtail because it looks like a fishtail. These are both gypsum selenite that is shaped into a fishtail. This is a rose. Sometimes they call it a desert rose, but it's a gypsum rose. What's that top one? Is that satin spar? I can't see. Yeah, that's satin spar. So it's got those long splinters. So what do we do with gypsum? That's what's most important. We make plaster out of it, plaster and drywall. That's why I said it's important that it's slightly soluble in water. We powder it really fine, and we can add water to it and make plaster or drywall mud, all sorts of stuff. It has some elements that are important for plants. We use it as a fertilizer or soil amendment sometimes. Sometimes people use it for carvings. It's also an ingredient in cement. We grind it up for cement. Anybody have any questions on gypsum? Cool. Let me show you a couple pieces real quick. So here's a piece of selenite. It's a fishtail. You can see the fork here at the end. It's pretty clear. This one is massive. You can see layers. This actually dissolved, this formed sort of when an ocean dried up, is kind of how it forms. There's a rose with its blades. And here is satin spar. It's probably much like your piece in your kit. It's got those long little fibers in there. It looks silky, like silk. All right, next we're going to talk about hematite, or the hematite family. So can somebody tell me what color your sample of hematite is? I'm interested to hear. Yes? Orangish red. How about yours? Black. Okay. Anybody else that's not much orangish red or black? Yours is just red? Okay. So those are common colors for hematite. Sometimes it could even be silvery, but it often oxidizes down to that orangish or reddish color. Its streak is always a red. I want you to do kind of a little streak. Sometimes it's a real dark red, real dark. Sometimes it's a little bit brighter or lighter. It depends on the type of hematite that you got in a piece. But it's always got some kind of reddish in the streak. So most often the samples you'll find will be massive. Sometimes you'll see what we call micaceous hematite or specular hematite. This is from the Upper Peninsula. It's really gorgeous stuff. It looks like just glitter glued together. It's absolutely beautiful. It forms in these hexagons sometimes, hexagon crystals. Not very often, but sometimes. I would love to buy one of these one day. I aspire to. These are gorgeous, the hematite roses. They're really cool. Sometimes it breaks into these splintery fashions. This is actually on the edge of a botryoidal piece. So this botryoidal is bubbles like grapes. And when it breaks on the end, you sometimes see these splinters coming up from the edges of these bubbles. So what do we do with hematite? I'm sure you noticed that your sample of hematite's pretty heavy stuff, right? It's pretty heavy because it's got iron in it. It's a good ore of iron. They mine hematite in Michigan. They mine it in Wisconsin, the Upper Peninsula. It's used to make iron and steel. These are called taconite pellets. That's a way that they used to move the iron ore from the Upper Peninsula to the steel mills. They'd mix it with a little bit of clay. And these pellets are a little smaller than a marble. It made it really easy to scoop it on and up into ships so they could carry it. In the Upper Peninsula, there's areas where the sand is actually just covered with this hematite. If you put a magnet down, you can just pick up a bunch of it. It's really heavy. Pick it up in a gold pan, too. This is called banded iron formation. This is a red chert mixed with hematite in between. It makes absolutely gorgeous jewelry. It looks really cool. Does anyone have any questions about hematite? Yeah.
You said that yours is pretty heavy.
Mm-hmm.
Ours is light.
Yours is pretty light? Would everybody say theirs is pretty light?
Yeah.
Does it have kind of like holes in it? Yeah, that's probably part of why it feels lighter. Tiny holes? Okay. I gotcha. What else? It sometimes could. What else? Isn't botryoidal hematite what? Called kidney ore. Yes, kidney ore is a nickname for botryoidal hematite. Absolutely is. What else? In the Upper Peninsula. Yep. What else? What's its hardness? Do I have it written down here? Hardness of 5.5 to 6.5. So about 6, give or take. All right, so next we're going to talk about pyrite. Pyrite's an easy one to identify. Why is it so easy to identify? Yeah. It's sparkly, but what else? Yeah. The color, right? None of the other ones are that goldish color. Pyrite is gold colored. That's why we call it fool's gold. So it's almost always this brassy yellowish color, unless it gets really rusty. But most of the time when you see it, it is a good goldish color. I want you to do a little streak. Pyrite has an interesting color of the streak. It looks a little bit greenish, almost black, but if you look at it, you'll see a little bit of hint of green in the streak. That could also help identify it. It forms in a lot of cool shapes. It forms cubes, sometimes absolutely perfect cubes that you could measure with a micrometer and they're perfect and they look like a mirror. I've seen some absolutely amazing cubes that you would think somebody made, but they were not made, they're natural. Sometimes forms octahedrons, same shape as that fluorite that we saw in Galena sometimes. Also forms these cool shapes called pyrite dollars or pyrite suns. They're radiating in these little flat discs. They're very cool. It has a conchoidal fracture. You don't often see that because it's a little too massive to see, but sometimes if you look real close, you can see small conchoidal fractures. Oftentimes it's pretty massive, and this is another shape, the special shape called a pyritohedron. These are actually 5 faces here. That's a really interesting shape that you see sometimes. So what do we do with pyrite? We make sulfuric acid out of it. It has sulfur in it, and it's very easy for them to make sulfuric acid. Long time ago, they used to have something called crystal radios, and the little crystal that was inside of there was pyrite back then. It sparks when you hit it on a piece of steel, so they used to use it as like a flint sometimes for starting fires or in a gun, flintlock gun. The chemicals are used to make paper sometimes, particularly back to the sulfuric acid. And actually, it's an ore of gold. sometimes. I went to a mine in Colorado, and we went down the mine, and everybody I was with was like, oh, the walls are gold. And then the person that we were with, the mine coordinator, said, that's not gold, it's pyrite. And it was huge layers of pyrite, but in that pyrite was actually a small quantity of gold that they could refine out. But boy, it looked amazing in this gold mine. It looked like the walls were gold. So let me show you, I brought just a couple pieces of pyrite. They're pretty heavy, right? Pyrite's heavy stuff. This is that pyritohedron shape. If you look, there's 5 sides on each of these. They're pretty cool. And this one's pretty massive. This is more typical. It still has small crystals on it, and it's sparkly and pretty, but this is more common to what you normally see. Anybody have anything to ask or add about pyrite? Yeah. Okay, so sometimes it looks almost silver. Yep, it's very reflective. Usually a pretty goldish color, though. All right, so next we're going to talk about copper. What color is the copper in your kit? Yeah. Yours is black? Okay, how about yours? It's kind of what on the side? A little green on the side. That's a real good observation. What else? Copper. It's copper colored, right? Okay, that's a good answer. I'll take it. What else? Bronze. Okay. So usually it's this reddish kind of coppery color when it's at least clean or pure. The more it stays outside, it kind of starts to turn brown like an old penny. You know how most pennies are kind of a dark brown color? And the longer it stays outside, it turns green. It gets what they call verdigris. That's like the color of the Statue of Liberty, right? That greenish color. This sample too. This is a huge piece of copper they pulled out of Lake Superior a few years ago, or a while back. So it doesn't really have a cleavage because it's very soft. It forms cubic crystals sometimes. They're not real common. Neither are octahedrons. Actual crystals of copper are pretty uncommon. Most often it's either going to be massive or dendritic. This is the dendritic shape they call it, sort of like a tree or roots. Sometimes it's wiry. You'll notice these little pokey wires sticking out of it occasionally. This is called float copper. They call it float copper because it was actually smushed by the glaciers in the UP. Pieces of copper that were carried along with the rocks, and they got smushed and rounded out into this shape because they kind of floated along the ground under the ice. They got smushed into these flat shapes. And you can see this bluish, greenish verdigris. That's kind of what the copper does after a long time being outside. When it breaks into this real hackly shape, real gnarly looking. It's a really, really good conductor of electricity. So we use it for a lot of things with electrical. Almost everything electrical uses some copper. The wires in the walls here and cell phones, everything. It's got copper in it. Pennies up until 1982, midway through 1982, they switched to zinc with the copper plating. But back before that, pennies were made out of copper. Now your quarters and your dimes are made of copper with a little cladding of nickel on the outside. If you look at the edge, you can see the copper. Pipes, they used to do a lot of plumbing with copper. Most old houses or older houses are done with copper. New construction, they're doing them with plastic now because it's a lot cheaper. Really old, really expensive houses had copper roofs. Sometimes you'll see in neighborhoods, just like over one window, there'll be a little roof, little eave made out of copper. And it starts out shiny, then turns brown, then turns green, depending on how old it is. We make all sorts of cool stuff out of copper. Let me show you the couple pieces of copper I brought. This one's pretty dark, pretty gnarly, a little pokey. This one too, it's got some green going on it though. Anybody have anything to add about copper? All right. We're going to move on to the feldspar family. So I want you to grab your pink feldspar. We call it K feldspar on the list because there's potassium in it. It's a type of potassium feldspar. There are different types of feldspar that have similar properties. Oftentimes color is one of the easiest ways to differentiate the different types of feldspar. The hardness is 6. I want you to remember that it is the 6 on the Mohs scale. Its streak is white like most things. Density, pretty average. New for this year, one of them is labradorite. This is a type of feldspar. It's a dark color. It's usually bluish or grayish. It can sometimes be white or other colors, but it's usually dark. It often shows a really cool property called labradorescence, where it actually shows different colors, often in the bluish, but can have other colors as well. Really cool play of colors. So it doesn't have potassium. That pink feldspar is potassium feldspar. This is a different type. It's almost on the other end of the spectrum. It has calcium and sodium. Don't really need to know that, but I want you to know it's different in that way. It's also common in mafic rocks. Remember we were talking about basalt and gabbro? This is a common mineral in those. So feldspar family, depending on what elements are in there, the potassium feldspar, K feldspar is pink. Then we talked about sodium and calcium in the feldspar, makes the labradorite. The other two types are anorthite, which is just pure calcium, and albite, which is just pure sodium. Those aren't on the list. So the shape, it's either monoclinic or triclinic. It's hard to tell the difference. I wouldn't ask you. Often tabular. Tabular means like a tablet, right? So all the angles are pretty similar, not really long and skinny anywhere. Cleavage, usually 2 planes that you can see. Sometimes you can sort of see a third plane. And fracture is uneven. We use it for glass. We use it for ceramics, plastics, paint, rubber. I have just a couple pieces I want to show you. So this is typical potassium feldspar. This is K feldspar. It's a light pink color. It's got a very pearly look to it and the luster. You can see this is a nice cleavage plane here, and so is this. This is a mixture of the pink feldspar and a greenish called amazonite. And this is labradorite, or a rock. This is actually, I would call it more like a gabbro, with labradorite crystals in it. And if you see, they've got some color play, that labradorescence. Anyone have questions about any of the feldspars? Yeah. No, labradorite is different from lepidolite. Those are two different things. Yeah.
What's labradorite's specific gravity?
I don't know. What else? I don't know. I don't know the density of it. It's pretty similar to the others. Did I not have it written down? 2.6. So the different types vary a little bit, but still it's a very common density, like most of the others. All right, next we're going to talk about kaolinite. So kaolinite's also, I think, an easy one to identify. It feels very interesting. It feels unique. It's got an earthy feel to it. It's got a hardness of about 2. You can scratch it with your fingernail pretty easy. It's almost always an off-white color. It often has little streaks of orangish or brownish somewhere in it or through it. You can never find any crystals. It technically has a basal cleavage. You really need to look at it under a microscope to see that. It doesn't break like mica does. It's important for, again, glass, cosmetics, toothpaste. Cosmetics particularly. You can feel how powdery it is. It turns into a really fine powder. They use it for blush and other stuff like that. One thing that's important to notice is it's made from weathered feldspar. So it's oftentimes the same sort of uses as feldspar because it's chemically very similar. Next, halite. What's another name for halite? Yeah. Rock salt. That's the word I was looking for. So halite is rock salt. We use rock salt to put on our food, right? We put salt on our food. We use it outside to melt the snow in the winter. It's used for, a number of other things. It's oftentimes either clear or white. It often has inclusions that make it darker or other colors. There are lots of funky colors that that halite can come in. That's bluish or purplish. I have samples that are pink. There's lots of different colors that it could possibly come in. It forms in cubes. That's the most common shape to see the crystals in. It also breaks into cubes. If you even look at the salt that you shake onto your food, if you look really close, they're tiny little cubes because they broke on that cubic cleavage plane. You almost never see a fracture on it. And it's very soluble in water, right? You know you can take and put salt right in water and dissolve it perfectly. So here in Detroit, here in Michigan, we actually have some of the best deposits of salt anywhere. This is directly below the city of Detroit, downtown Detroit. They are mining. This is a scale picture, I believe, of how deep it is. And there's a number of layers that they mine. They stopped mining for a number of years. They started it back up about 5 or 10 years ago. So they're constantly mining. If you go downriver, you can see these big heaps of salt right by, I don't know where it is, but off the expressway, you can see the heaps of salt. They're blue. They put some dye in them or something to make them blue. They're not blue when they dig it up. But it's really cool. So directly under downtown Detroit, we mine salt. We also get some from up near Port Huron. We have a different mining process where we pump water down and then let it dissolve a bunch of salt, pump it back up and dry out the water and collect the salt crystals. So that's another method of mining salt. I think this picture is in Poland. This is a big underground cathedral. They have lots of salt in Poland too. And the old salt mines they use for interesting things over there sometimes. You'll notice salt sometimes has layers because it is basically evaporated seawater quite often. Oh, another use we use is water softener salt. So if you're on a well, you got to put salt in your softener all the time. It helps recharge the resin beads in there. Anyone have questions about salt? Yeah. Isn't halite very fluorescent? Not usually. It is sometimes, though. I do have some pieces of halite that are very fluorescent. It's usually not too fluorescent. Ron, I'm going to hold your story off because we're keeping them really late, okay? Thank you. Talc is number 11A. Talc is the number 1 on the Mohs scale, which I've got to tell you, a lot of samples of talc that I have seem to be harder than what I would think a 1 should be. You still can scratch it with your fingernail, but sometimes it's a little harder than you would expect. Again, talc can sometimes form more mineral-like or more rock-like, so it can vary in properties a little bit. It's usually either waxy or pearly or greasy, and it's very soft. So most often it's like this massive foliated kind of stuff. Sort of looks like schist a little bit, because truthfully it forms in sort of a similar way quite often. It can sometimes break into these splintery pieces. Not always, but sometimes. Ground up talc is baby powder, right? That's the most common use for talc, or at least it used to be. I think they're going away from it now. But again, they use it in cosmetics, all sorts of other things. Carvings, soapstone carvings are made of talc. Soapstone is talc. So talc is pretty cool stuff. I have a neat piece you can feel later if you want. It's really got an interesting feel. That's why we call it soapstone. It feels like a bar of soap. So next we're going to talk about bornite. Bornite sort of looks like pyrite, right? It's got a similar density When you feel it, it's got a similar heft. The difference is that it's got different colors. Pyrite is always just that gold color. Bornite oftentimes has different colors of the rainbow. Sometimes it's bluish or purplish. Could be almost any color. But otherwise it looks and feels similar to pyrite. You don't usually or hardly ever find crystals. It's almost always a massive material. So these crystals are very rare. It's usually irregularly, unevenly broken. We call it peacock copper. That's a nickname. It does actually have copper in it. And the peacock part is because it's got all the pretty iridescent colors, like a peacock feather. Anybody have any questions about bornite? Yeah.
How important is chalcopyrite? Years ago, when I was 17-year-old, I was doing Rock Hound.
Yeah.
There was something in the box, I remember there was some confusion between bornite and chalcopyrite.
Yep, chalcopyrite is another mineral that's different from pyrite and bornite. And it doesn't usually have as much of the rainbow colors. It looks more like pyrite, except more orangish or rusty more often. It's hard to identify between pyrite and chalcopyrite, but that's not one that we're going to deal with. So, next is the mineral olivine. This is another one that's special for this year. So olivine is easy to identify for its color. It's almost, or it is always, this greenish or yellowish green, some kind of light green color. It rarely but occasionally forms into sizable crystals. It's usually either massive or granular, almost always. Its density is 4 grams per cubic centimeter, so it's a little bit heavier than normal. It has a conchoidal fracture, and it's common in igneous rocks. This is actually a beach in Hawaii that is almost entirely olivine. It's a green beach, which is really cool. The volcanoes that were in that area were pumping out just tons of rocks rich in olivine. When you have gorgeous, really pure olivine, it's the gemstone peridot. Okay? And this is really an excellent representation of all the colors that you might find olivine in. It's got a couple of properties that make it good for doing casting in it. It sticks together with just a little tiny bit of water. It's heat resistant. So they use it for aluminum casting. It's not too important to know that. I do want to show you a piece of olivine that I brought here today. So this is called an olivine bomb. It's all granular on the inside. And there's little tiny pebbles of olivine. And the outside is all burnt and charred. So this actually shot out of a volcano, just like the obsidian bombs that we looked at and the Apache tears that were single pieces that came out. This did that too. Olivine has a very high melting temperature and requires a lot of pressure to melt. So it oftentimes stays as a solid piece mixed in with lava, or magma, I should say. All right, the very last one, this is our last slide. Don't have it, sorry. Is hornblende. So this one is also new for this year. It's easy to identify compared to the rest of them, the rest of the minerals you have to look at, because of its colors and the way that it breaks. It's almost always this darkish, blackish, greenish color, and is kind of sparkly. It usually has some cleavage planes that you can see, that it sort of looks maybe a little fibrous quite often. It sometimes forms hexagonal crystals. Not always, not often, but you'll sometimes see them. Again, they usually have a flat termination or sometimes just like a couple of faces. Let me show you. I brought a couple of pieces for you to see. So here's a piece. It's kind of got that same pearlescence that some of the samples of feldspar have. And you can see these cleavage planes that it almost looks like it has layers to it a little bit. Here's a crystal, and it's got a termination there, little two faces on it. but it doesn't really look like any of the other minerals that we have. So it's pretty easy to identify compared to the others. All right. Thank you so much for sticking around with me. This was a really long class. I really appreciate all your patience. If you have questions, you can come up here. I'll be happy to ask them or answer them.
This is Rock Hound, and I think now that I've studied Rock Hound, this wasn't my first choice at first, but now that I studied it, I think it would have been my first choice.
Or calcite.